I'm Chad Reynolds.
And I'm David Freiberger.
And on this video, you're going to learn how to understand and set ignition timing on your engine.
Before we show you how to set ignition timing, you've got to understand what it is. Go back to the 4-stroke cycle of intake, compression, power, exhaust. Now on the power stroke, the spark plug fires and starts an explosion that crams the piston down the cylinder and makes horsepower for you. But in truth, that spark happens a few degrees before the power stroke at the end of the compression stroke. In other words, right as the piston is coming up for compression, just before it reaches top dead center, or TDC, the spark plug fires. That distance before top dead center is what is known as ignition timing. Ignition timing is typically read from a mark that's on the harmonic balancer on the front of the engine, and the 0 point represents top dead center from the number 1 cylinder in between the compression and power stroke. This 0 mark will have been set by the factory on your engine or perhaps by the machine shop that built it for you, but it's critical that that mark be set exactly top dead center on number 1. Now, I'm going to rotate the engine here with a breaker bar to simulate what happens here on the timing tape so you can see what we're talking about. Right now we're before top dead center and the piston is on its way up. So right here, if I stop, the piston is now at 20 degrees before top dead center, and it's moving on its way up the cylinder. There's 10 degrees before, 5 degrees before, and then I went a little bit after, but that's roughly 0, or right at top dead center. Now the piston is moving back down the hole, and now it is 10 degrees after top dead center. So as the engine rotates, the piston comes up, stops for just a millisecond at top dead center, and starts to move its way back down. Now that's the mark that we use to determine ignition timing. Now that you understand how the MSD timing tape on the damper relates to the piston position in the engine, you can understand that I have it right now at 12 degrees before top dead center. That would be a typical initial timing adjustment for a small block Chevy. Now, if I were to advance the timing, that would mean making the number larger or more degrees before top dead center. If I were to retard the timing, it would mean moving it to less degrees or a smaller number before top dead center. So if you're at 12 and you change it to 20, that's advancing the timing. If you're at 12 and you change it to 0, that's retarding the timing. Now that we've described what an ignition timing number means as far as crankshaft degrees and the position of the piston in the cylinder, I can tell you about the 3 aspects of ignition timing that you need to know. The first of those is initial timing setting, also known as idle timing. That is the total ignition advance set when the engine is idling. The next aspect is total ignition timing, or the greatest amount of advance that the engine achieves at higher RPM. The third thing you need to know is ignition timing curve, which is the rate at which the ignition timing advances between the initial timing and the total timing. Now I've explained that there's an ignition timing curve between initial timing, which is a lower number, and total timing, which is a higher number. But you might ask, why does ignition timing need to advance as engine speed increases? Think of it this way. We always want peak combustion pressure to happen at the same point in the piston travel, say about 10 degrees after top dead center on the power stroke. Now let's assume that there is a fixed amount of time between when the spark plug fires and when that point of peak pressure occurs. So if that is a fixed amount of time, you can see that as engine RPM or speed increases, you need to ignite the spark sooner so peak combustion happens at the same place regardless of engine speed.
Now that you've got the theory down, it's time to hook up your timing light and check your initial timing. Here's how you do that. If you've got an MSD timing light or anybody else's, what you're going to do is hook up your cable to power and ground on your battery. This does not plug into the wall. And then also take this pickup and hook it to your number 1 spark plug wire. You'll note that on some timing lights, there's an arrow that points in the direction of the spark. In other words, that arrow needs to point at the spark plug. You hook this up to the number 1 spark plug wire. Every time the number 1 spark plug fires, this sensor picks it up, creates a strobe effect with this light so that you can read the timing mark on the balancer.
Now here's what Chad is seeing through the timing light. You can see the initial timing setting is about 12 degrees right here. Now watch as engine RPM increases, you can see that the timing advances up to about 33 or 4 degrees. It'll start to jump around up there, and that's not actually what the engine's doing, that's a result of our camera's shutter speed. But anyway, you get the point that as engine RPM increases, so does timing advance. We just showed you how to read timing, now I'm going to tell you how to adjust it. First thing you need to do is loosen the bolt that holds your distributor hold down clamp so that you can rotate the distributor housing. Now on this Chevy, where the rotor returns clockwise, you would advance the timing by turning the distributor counterclockwise, or retard the timing by turning it clockwise. Here's how that looks on the timing tape. Now watch as, here's our base timing, this is going to be advancing it, here it comes back to where it was, and now I'm retarding it. Now we're going to look at setting the total ignition curve on this engine, which is defined again by the point between initial timing and total timing and how fast it gets there.
The most important thing for maximum performance is total timing. And on a typical small block Chevrolet like this, you're aiming for between 34 and 36 degrees. So what we're going to do is, using our timing light, fire up the engine and rev it up to somewhere between 3,500 and 4,000 RPM wherever our timing quits increasing. When we get it to where it's stopped adding advance with the distributor, I'll adjust the distributor so that our timing reads at 35 degrees, and then we're going to lock down the distributor.
After we locked in our total timing at 35, we checked our timing at idle, our initial timing setting. We found out that it was 19 degrees. What that means is that this distributor has 16 crankshaft degrees of total timing in it, between 19 and 35. Now honestly, for an engine with a rowdy cam, that's probably about right. A tamer engine could use 12, 15 degrees, something like that. The thing about the MSD distributor is that all of that is easily adjustable, and we'll show you about that right now. Now we get into the guts of the MSD distributor so that we can change our timing curve. Every Pro Billet kit comes with a variety of springs and a variety of stop bushings so that you can adjust the total advance curve in the distributor according to the charts on the side of the box. You can change the total range of timing within the distributor and the rate at which it goes from initial to total. The lighter the springs that you put on these advance weights, the faster the curve. The heavier the springs, the slower the curve. In addition to changing the rate of the curve with the springs, you can change the overall sweep of timing inside the distributor with these little bushings. And you have to get an 11/32 wrench in here, right underneath that advance weight, and take off a little nut to get to that bushing. And finally, there's the one thing that we can't really tell you here, which is exactly what the right advance curve is for your car. That's going to be a matter of trial and error. In general, if your car has more compression, a rowdier cam, if it's lighter, if it has lower rear gears, a looser converter, that can generally accept a faster curve. A car that's going to need a slower curve would have lower compression, a smaller cam, it would be heavier, have highway gears, a tighter converter. That's sort of the general trend, the way things are going to go. But you can mess with it. It's pretty easy to change those springs on that Pro Billet distributor, but you can make it even easier on yourself and not have to deal with any centrifugal advance mechanism if you pick up one of those MSD digital E-curve distributors, at which point all you have to do is change a couple of switches here with a little tiny screwdriver, and you can set your entire ignition curve electronically.
Don't forget that all the information you need is right here on the side of your distributor box. It tells you what springs and what bushings will give you what combination of rate and total timing sweep. Yeah.